Thank you very much for being here to listen to us. It's an honor for me to speak to such a distinguished audience in NYU. I actually graduated not very far from here. I remember sitting in this well, not this auditorium, but another auditorium very close by to listen to one of my teachers. It's very funny to be here again and be on the other side of the auditorium as a speaker. Now, the challenge with Clevaligner is that there is a paradox. What paradox? The paradox is the following. You all want to have control, but do as little as possible. And that's paradoxical. And that's the reason why in office, if we do in-office printing, we have control, but we do a lot. If we work with other suppliers, then we don't have control. We're disappointed, we can't make any changes, it takes time. So the paradox is a real challenge. And the whole point here, if I understood well, is that we can have treatment proposals so that we don't have to spend too much time on except, for instance, and we can have something that will enrich our own artificial intelligence and will match our wishes. If you receive a treatment simulation from a liner company that has already treated 70 million patients, it means 17 million patients treated by Dr. so-and-so, with sometimes bad doctors or bad treatments. The data quality, the deep learning, the artificial intelligence is very important. And that may be a very positive point. And I don't have much time, but I would like to show you a case that is only 5 weeks old. We can't go back too much, not a long follow-up. This is one of a patient called Asia Panier. She has a small relapse of a previous orthodontic treatment, and she comes to us looking like this. It's not too bad. It's relatively healthy in terms of oral hygiene and environment. She's a class 1. So no, we're not going to take too many chances with her treatment. However, things have moved a little. She has a bonded retention wire, but things have moved a little. Maybe because the retention wire doesn't include the 2 cuspids, and when it was debonded, it was not rebonded, and the incisors moved. You don't really tell up front, but the patient sees it. She's very unhappy because she sees it in her face. And the point is to understand how Clevaligner works for this kind of patient and how we can have a feedback. We talked about feedback earlier with Oscar, the little boy. So that's a pan X-ray. Wisdom teeth have been removed from the maxilla. This is a cephalometric X-ray, nothing really worth writing home about. I don't know how this is going to work, but I'll try and show you the presentation. The process is a bit like it has always been. We send an STL file, radiographs, photographs. There is the prescription, because we need to know what we're going to correct the class 2 or not, close spaces because of a missing molar. We need to send a prescription because otherwise there's no treatment simulation. The prescription is fairly conventional. I wouldn't say it's really almost bare bone, but it's not too complicated, it's limited, so you don't tend to spend too much time, and at the same time the prescription is sufficient to provide you with a matching strategy. There's another element that we're working on. Unfortunately, I cannot speak about it, it's still privileged information. Something really innovative. It is an interface. I'll call it an interface. It is an interface in the prescription process, an interface that is innovating and gives us better control versus other aligner programs or other aligner manufacturers. Then we receive the final view of the treatment. So that's where we start, actually. We decide where we are going, what is the final result. You always say we have to work with the end in mind. That's exactly what we're doing. We start from the end. Ooh, I can't remember who said that, maybe Alexander, but he said always begin with the end in mind. And so we have the first image immediately. We don't get the first image in 3 days' time, we have it now. There is something else that Clevaligner is working on. Receiving information instantaneously. If you see the patient at 9 in the morning, if you're quick enough, you may have your aligners printed mid-afternoon, the same day. Well, maybe the patient will not come back the same day, but that's the idea. Same day aligners with a certain flexibility, whether it's a simulation or the final manufacturing of the aligners. So back to our topic. We received this patented interface, so I will not go over it. We received the simulation to change the final position, and in the meantime everything is being churned by the machine, and we received the treatment stages, sequential destabilization, etc. And then we make a few changes if we need to, stripping, more stripping. I'll try and show you how it works. What is interesting is, I think maybe Charlie can answer this question. What is interesting is we don't want to work on treatment categories, but rather on numbers of aligners. I'll give you an example. For this case, for those who are familiar with Invisalign, we might say, okay, we're going to treat this patient with an Express, but Express is not maybe it's not enough because it doesn't move the molars. So every system has its limitations, and we really have to break through those limitations to be as close as possible to the doctor's desires and wishes. We want to have an interface that will immediately call up radiographs or pictures whenever you need them. So you don't need to work on 2 different computers. You can just simply switch from the photograph to the model. In this case, then you have comments which you're very familiar with, except one, this one. This one works like what they have at Invisalign. This is what they call a scenario. There are figures you're not familiar with. The blue lines are the tooth movement. For instance, take the second right maxillary molar is going to move from stage 2 to stage 6, but that can be changed. If you want the second molar to move at the end of the treatment, you can change it. If you want it to move at the beginning of the treatment, you can change this. So we have control over the movements we want to obtain. I'll give you an example. If tooth number 11 is suffering from periodontal tissue loss, and I want it to move over 4 stages, you might say, okay, I want this tooth to move more slowly, so it will be more than 4 stages. It will be a longer movement, but a softer one. Here you see there's 0.3 mentioned. 0.3 means that I have a parameter, a default parameter, that you can also change, but the default parameter is 0.3 millimeters per stage. If for any reason such as periodontal tissue weakness, you want to move to 0.1 millimeters per stage, obviously this means the number of aligners will increase, but the movement will be softer. And you can do that for all the teeth or for just one tooth. Conversely, but that's more risky, you can ask one tooth to be moved more quickly. For instance, a very simple translation movement, a 17-year-old patient with beautiful roots, you can ask the tooth to be moved 0.5 millimeter per stage, so much more quickly. It doesn't change the number of aligners, but it's interesting. And then we have number 5. It's the same thing with degrees, 5 degrees per stage. Finally, the next figure, 4. 4 is the number, can't remember, it's the stage at which the movement will start. You see, there are some differences here. Bear in mind that several orthodontists are working on the project. We ask for their advice and their opinion, and the first thing we asked is, what do you expect? And we submitted the paradox. They always say, we want to have control, but we want to do as little as possible. So that's the paradox. Now, I'd like to go inside Asia's mouth, if I may. And we see that the aligner at stage number 5 is well adjusted. She is changing her aligners every week, but the aligner is well adjusted. There are no adjustment defects. This is the occlusal view, showing that her teeth are starting to align. So everything is going really well. It's obviously very difficult to judge a plastic, a clear aligner. But it seems that the plastic material is okay, neither too thick or too thin or too stiff or too soft. It seems to be okay. The patient reported some sensitivity for 3-4 days, nothing really abnormal. This is week number 5, alignment of the the lower arch. Here we have the profile. It's as if we were doing an Invisalign control at 5 weeks. Aligner control, Clevaligner control at 5 weeks. We check for adjustment, and that's it. We can move on and ask for the and give the patient the other aligners. Here you can see on her smile that the aligner is looking really well. It's very aesthetic. The plastic is super transparent. There are no lines that can be seen in some brands of aligners. There was a long discussion as to know whether we wanted to cut the aligners along the tooth crown or 1 millimeter above the tooth crown into the gum. I think most of the orthodontists voted for cutting the aligners along the crown scallops, but depends. There could be different preferences. This is an aligner. This is an aligner after 1 week of use. It looks great, it looks new. It's been in the patient's mouth for a week. Probably the patient has very good oral hygiene, but it does show that the plastic is very high quality plastic. I have not printed the aligners myself in my office, but the idea is to be able to do this quickly and be able to print the aligners quickly. And I received them really quickly. I mean, I didn't print them myself, they printed them from me, but I got them in a matter of days, 6 days. Thank you very much for your attention.